Well, hello, welcome back. And today we are gonna be doing lesson 12.1.4, reciprocal trigonometric functions. All right, so I'm not gonna lie, this is one of my favorite lessons in high school because it was always like a puzzle, and you'll figure out what I mean by puzzle. So you gotta figure out how to like break it down and then build it up and then get into a single cosine tangent or cosecant or secant so that you can solve for the answers. And honestly, it was fun. If you kind of like puzzles, you might enjoy this. Some of you guys are like, well, you're a math teacher, you're supposed to like math. Hey, I take offense to that. I do other stuff beside math. But I mean, if you know math, you're pretty much in the green, physically, money-wise. So, don't you go hating on math. All right, before I go on my tangent, kidding. Let's jump right into it. So, we're gonna bring back r, the radius. So for this part, remember, r is always positive. No negative radius. So, and you also, so let's use this one. All right, we have x, y, and r, right? So we're gonna have a new Pythagorean theorem identity. Well, it's the same Pythagorean theorem, but instead of c, you're gonna have r. So our new one's gonna be x squared plus y squared equals r squared. This is gonna help you immensely for this section. Other tools that you can use to break it down, build it back up, find missing values. So let's use this and let's sort of remember what we learned. So tangent equals sine theta divided by cosine theta, right? Right here. And we remember that cosine is x and sine is y. So we can say y over x, which will equal 1/2 divided, because y is sine, divided by √3 over 2. A copy dot flip. I don't know if you guys remember that. Not remember, use that growing up, because I did. And then we dot for multiply and then flip it, 2 √3. So 2's cancel and you get 1 √3, which equals, I'm running out of room, you guys might be too. I'm sorry, but I'm gonna write really small, √3 over 3, right? Because we multiply the top and bottom by √3. All right, cosecant theta equals 1 over sine theta. So we can say 1 over y, right? Same thing. 1 divided by 1/2 equals 2. So when you see sine theta, cosine theta, and you're given a unit circle, remember in your head, what's x, what's y? And so on and so forth. You know, sort of get yourself in the habit, learn those stuff. So secant theta, secant is 1 over cosine, so it's 1 over x. Get 1 over √3 over 2. So then you get 2 over √3, multiply top and bottom by √3, times by √3, times by √3. That's what I did up here. That's how I got √3 over 3. And you'll get 2 √3 over 3. So cotangent of theta, 1 over y over x, right? Tangent theta, 1 over tangent theta. Tangent theta is y over x, right up here. So then we can just say x over y, which would equal √3 over 2 divided by 1/2, which would equal, oh man, I'm gonna go down here, √3 over 2 times 2 over 1. 2's cancel, and you get √3. Right? So don't stress. You're gonna have a lot of time to practice these if you are stressing out about it. So let's continue. Find cosecant if tangent theta equals 3/4. Tangent theta equals y/x. Write it down. Y equals 3, x equals 4. Right? Or y equals -3 and x equals -4. So we have to write within 1 unit circle what it can and cannot be. But we still don't know r, right? So r equals the square root of 4 squared plus 3 squared, which would equal square root of 16 plus 9. Which would give you 5. The square root of 25 is 5. And remember, r is always positive. That's why I wrote it. So now that I found r, we're going to find theta for tangent. Tangent of theta equals 3/4. So we know that theta is in quadrant 1 or 3. So let's find it. Let's draw our unit circle. And find sine theta so that we can find cosecant theta, because we know cosecant is the opposite of sine. So we kind of have to, like a puzzle. You're going to find tangent of theta. You're going to find which quadrants theta are in for 3/4. You're going to find r equals 5. And then you're going to use that, because now we're not, r is not 1 anymore. So we're also introducing that concept. So I know that's 5. This is 3, and that's 4. And I also know this is 5. This is 3, and that's 4. I mean -3, -4, right? So I knew that there were 2 triangles, so 2 thetas. So let's find them. So sine of theta equals y over r, which would equal 3/5. Or sine of theta equals -3/5. So what's the cosecant for essentially tangent theta equals 3/4? But we've got it down as sines, and we just need to flip them, right? So cosecant theta equals 5/3. Flip that one. Or cosecant theta equals -5/3. Doesn't matter where you leave the negative. You can leave it with a 3. I just brought it back up because it's more proper. Right? Those are my 2 answers. So let's do that. Secant theta equals 2. But can we write secant theta as to something else? Well, I know secant theta equals 1 over cosine theta. So if I flip 2 and make it 1/2, that would equal cosine theta. So cosine theta equals 1/2. See, you gotta, pick and choose which one works. How do I break it down to find cotangent of theta? So then I could build it into cotangent of theta. Right? You're using these identities. You don't know which direction to go. You just know that you got to find all r, x, and y. That's your main goal for this part. But they'll get more complex, and you'll see. It's fun. It's a good time. So, draw my unit circle. And cosine of 1/2 occurs here and here. Right? So I know that this is pi/3, and this is 5pi/3. So, because I know them both, I know that this is 2, and that's 2. When you do the when you do the trig identities. And we've already gone over that, so if you have any questions about that, please review it from previous videos or come to office hours and we'll review it together. So don't be worried, because you know that this is 1/2 right there. So now that we know that it's in the first and fourth quadrant, x equals 1, y equals -2, y equals plus or minus 2. So now what's r? R equals square root 1 plus 4, which would equal root 5. So r is root 5. So we know that cotangent of theta equals x over y, right? I did the math right up here, 1 over y over x. Proved it. So what are my answers? How many answers am I gonna have? 1 or 2? 2. 2 and -2, right? So cotangent of theta equals 1/2, or cotangent of theta equals -1/2. So those are my 2 answers. All right, let's do the next one. Next 2. If tangent theta, find tangent theta if sine theta equals 4 over 5. So once again, we're gonna break it down, find all our possible values. And we know that sine theta equals y over r. Pretend that 3 is an r. So we know that y equals 4 and r equals 5. So on my unit circle, it's going to be in quadrant 1 and 2, because those will both give me positive sign. So right there and right there. Positive, positive sign. And I know that 5, 5, and 4, and 4. But I'm going to get a positive and a negative for an x. If you guys remember your special triangles like 3, 4, 5, I don't remember the other ones. That's the only one that stands out to me. You can automatically fill that in. If you don't, Pythagorean theorem. X equals plus or minus, because I know there's going to be positive and negative, 25 minus 16. 5 squared and 4 squared. 5 squared minus 4 squared. Equals plus or minus root 9, which equals plus or minus 3, right? Positive 3, negative 3. So if I find tangent theta will equal y over x, which would equal 4/3, or equals negative 4/3. Doesn't matter where you put the negative. Remember, here are my answers. And that's it. Use your tools. I introduced to you the new Pythagorean theorem in terms of r. Not new, but we replaced c with r, a with x, and b with y. So r is always going to be positive. You guys know that. We're good to go. So secant theta equals 5 over 4. Or cosine theta equals 4 over 5. Right? So which quadrants do you think it's going to be? Right. First and fourth. Because I forgot which one's y, which one's x. X over y, right? X over r. X and r. So r equals 5, x equals 4 this time. So we know it's going to be in the first and fourth quadrant again, like up here. Let's draw it. Sorry if I'm drawing these too small. I'm hoping you guys can see it. So I know it's going to be here and here. Half a bow tie. Right. 5, and 5. So I know this is 4 and negative 4. So I know that it's going to be a positive answer for my, oh, not 4, negative 4. 4, right? You guys are like, oh my God, he did it wrong. Don't worry, I got this. All right, x equals 4, y equals 5. And I know I'm going to get two answers. So y equals plus or minus root 25 minus 16 again, which I'm just going to say plus or minus 3. I did the math on this one, right? So I'm going to get 3 and negative 3. So I have everything. I know it's in the first and fourth quadrant. Now I can find cotangent theta, which equals x over y. So cotangent of theta equals 4/3 for the first quadrant, and cotangent of theta equals negative 4/3 for the fourth quadrant. Those are my answers. There we go. Good to go. So, cotangent of 6 pi. I can rewrite it as 1 over tangent of pi, because I'm using my trigonometric functions, which equals undefined. Can't have an answer for tangent of 6 pi. If it's 1 over undefined, it's still undefined. Because remember, it's 0 and 2 pi. Undefined, 6 pi is a coterminal angle of that. So let's do number 2. I'm going to write y over sine 11 pi over 2. Because those are equivalent to each other. So I'll get 1 for the top. And what do I get for 11 pi over 2? Coterminal angle, 11 pi over 2. Pi over 2, it's going to be negative 1 because it's going to end up at the bottom. Just count them. Go pi over 2, 3 pi over 2. Add another pi and you get 4 pi over 2. No, not 4, 5 pi over 2. Add it again, 7 pi over 2. 9 pi, 11 pi. 11 pi is going to be at the bottom. So, get used to remembering them. Get used to coterminal angles, and you'll be fine. Alright, so let's do this one. Cosecant pi over 4. What's it going to be? It's going to be 1 over sine pi over 4, because we already did that. What do we get? 1 over root 2 over 2, which equals 2 over root 2, which we multiply top and bottom by root 2. And we get, yep, root 2. Nice. Simple. Easy. We know what pi over 4 was. We knew it was root 2 over 2, and we just went with it, did the math. Review them if you don't know what I'm talking about. Seriously. Memorize them, review them. Do whatever it takes to get you to remember them. That's why we had you do those quizzes. The unit circle quiz. Secant 420 degrees equals 1 over cosine of 420 degrees. So, I can also rewrite it in terms of another coterminal angle, which equals 1 over cosine of 60 degrees, right? So, if it's 1 over 60 degrees, cosine equals 1 over 1/2. Remember, unit circle. Remember that. We also had you memorize the this. I subtracted 420 degrees by 360 to get 60 degrees, right? So essentially subtracting 2 pi. So, you get 2. If you have any questions on this page, remember, ask me when we see each other. Don't hold them. If you have any questions, some of you might also have the same questions. All right, let me flip my own pages. There we go. Let's go. So tangent of x equals 1. So when do they equal? Use your knowledge of the unit circle. Solve for the following where 0 to x to 2 pi. So we don't need to add 2 pi n to your answers, right? Because it's telling you it's only one revolution. That's it. So tangent of x equals 1. What would give you 1, right? The first quadrant and the third quadrant. So x equals pi over 4 and x equals 5 pi over 4. Tangent is positive in these two quadrants only. First and third. So cosecant of x equals 1/2 can be rewritten as sine of x equals 1/2. We know that's going to be in the first and second quadrant. So x equals pi over 6, and that's supposed to be comma, x equals 5 pi over 6, right? So we kind of went backwards a little bit, and helping you just remember them, first, third, which quadrant goes in where, and whatnot. So we have a positive tangent, first and third again. X equals pi over 6, because it's pi over 6 for the radians, and 7 pi over 6. So first and third. Cotangent of x equals -1. Now we're getting to the negatives. We know tangent of x equals 1 over -1, which equals -1 as well. It's kind of cool when you get both answers being the same. X equals 3 pi over 4 and x equals 7 pi over 4, because I know that they're in the second and fourth quadrant. Look it up if you don't believe me. Look them up. So let's do this one. Secant, opposite of secant is cosine, which equals 3 over -2 root 3. Multiply both sides by root 3, and I'll get -root 3 over 2. Right? Because if I multiply the root 3's, you get 3. 3's cancel. There we go. Let me clean my eraser for a sec. Alrighty. So we know that it's going to be in the second and third quadrant, but where x equals 5 pi over 6 and x equals 7 pi over 6. Second and third. All right, let's do the next one. Cosecant of x equals undefined. Well, I guess we just got to stop and undo this one. Kidding. We can do it. Because we know that sine of x, the opposite of cosecant, equals 0 when cosecant is undefined. So x equals 0 and x equals pi. Because it goes from 0 to pi. Sine only equals 0 at 0, and pi from 0 to 2 pi. So let's do cotangent of x equals -root 3. Opposite is tangent of x equals 1 over root 3, -root 3. Times by root 3, times by root 3, and I'll get -root 3 over 3. Easy. X equals 5 pi over 6, and x equals 11 pi over 6. So I knew that because it was in the second quadrant and fourth quadrant. You guys are gonna hate me by the time I say that, but hopefully it's drilled into your head which quadrant it is. Just be like, I know. That's a good sign. It's a good sign. If you're annoyed by me, means you have a good understanding, good grasp of it. Guess what? I'm gonna do it one more time. So opposite of cosecant x is sine of x. So I gotta flip that and get 3 over 2 root 3. And I already did the math over here, except there's no, there's no negative, so it's gonna be full positive. And I'm gonna get root 3 over 2, right? I already did the math, no need. X equals pi over 3. And x equals 2 pi over 3 because they're in the first and second quadrant. First and second. I like how my arrows get bigger when I draw them the second time. I know you guys have noticed that too. All right, let's do these ones. This is the fun part I was talking about. You guys are like, fun? Fun? You guys are hyperventilating. So, whenever you see problems like these, try to simplify first, like left side or right side. And yeah, just go for it. Simplify it. So we're going to do sine squared x. This means that there are 2 sines squared. So it's sine of x times sine of x. All right. Times 1 over sine of x, right? Because that's the opposite of cosecant, equals square root 3 over 2. Because I changed cosecant of x. So I know that disappears, and that turns into a 1. And I'll get sine of x equals root 3 over 2. And now I can answer it. Which quadrants are they in? First and second. So x equals pi over 3, and x equals 2 pi over 3. There we go. Good to go. It's like you got to figure out how to break it down, and when these get more elaborate, they get more fun. Don't look at me like that. I know, I could see it through the video. Sorry, I'm such a weirdo. Whoops. So secant squared x, we can say that it equals cosine squared x. And then it's multiplied by cosine of x. That disappears, that changes to a 1. And all that equals 0. So 1 over cosine of x equals 0. And you're thinking, what? You're thinking to yourself, but this can't happen because you just get 0. You can't even cross multiply. So we can say that this equation, yes, from lesson 1, we're bringing it back. We're going full unit circle. Okay, I'm not gonna stop. This equation is never true. Remember, 12.1.1, sometimes true, never true, always true. We're bringing it back. So, see, like this one, that's the one I find fun because it's challenging. If it were easy, it'd be boring. And I'm bored a lot, so now you know. All right, think about an algebraic way to get rid of the fraction. So how do we get rid of cosine of x? I'm going to multiply both sides, or I'm going to cross multiply. I'm going to get rid of the cosine of x from the right side and move it to the, get rid of cosine of x from the right side, move it to the left side. So I'm going to cross multiply. I'm going to get secant squared of x, this is over 1, times cosine of x equals 2. So I've put all the secants, cosines, sines, whatever, to the left side, and I'll put all the whole numbers or irrational, like square root 3 over 2 and whatnot, on the right side. And then we're just going to solve, right? So now that we've gotten to this level, what do we know about secant squared x? It's 1 over cosine squared x times cosine of x. which also equals 2. So that cancels. This changes to a 1, and I'll get 1 over cosine of x equals 2, right? This can happen because I can flip it back around, and I can get cosine of, whoops, I didn't like that. I can get cosine of x equal, because I need to have cosine of x in the numerator, equal 1/2, right? And we know that there are solutions for cosine of x equals 1/2. Which quadrants are they in? First and fourth quadrants. So what are x? X equals pi over 3, and x equals 5 pi over 3. So first and fourth, right? All right, let's do this one. Cosine of x times secant of x equals 1. So let's just move secant of x into a cosine form. Cosine of x times 1 over cosine of x, right? Which equals 1. Cosine of x divided by cosine of x equals 1. So 1 equals 1. Guess what we're going to use? This is always true, right? So that is the end of this lesson, 12.1.4. These are going to get a little bit more difficult in the upcoming weeks, but nothing you guys can't handle. And if you guys think of it like a puzzle, I'm certain you guys can solve that. All right, well, I'll be seeing you in the following week. This is the last video for this week. Thank you, and enjoy the rest of your day.